Welcome back. This video will explore creating a real, though simple, Python project. We'll write a bit of Python code, though the intent is not to cover Python in this video, but rather to make sure that Python works in the first place. And finally, we'll cover how to execute Python code in various ways. Unlike some programming languages, Python doesn't require a specific structure to your project. Commonly, you'll have several subdirectories in a main project directory, some to hold data files, others to hold source files, and still others to hold results of running programs. Let's start by creating a directory to hold our project. I've already started git bash here, and so I'm going to have to make a new directory. And my current directory is /, which on Windows will require administrative privileges to write to, but I can change my directory to my desktop. And now I'll make a directory called example1, mkdir space example1, hit enter. And let's go into it, cd example1, hit enter. And now let's make a few directories in here, mkdir data, mkdir, and we can combine this. I'll do source and then res. If we do ls-pal, we see we have a folder with 3 subfolders, data, result or results, and source, src. We'll create a first program in the source folder. To do that, we'll need a way to edit the file. Python programs, they have to be plain text. Plain text means that the underlying bytes of the file are all text characters in some known text format, rather than some proprietary format such as a Word file. There are a great deal of editors out there, and any plain text editor will do. For example, there's a command line text editor built into most shells, in this case git bash, called Nano. There's also development tools that we'll cover later, including Visual Studio Code, another one called Jupyter Lab, that both contain plain text editors. For this video, though, let's explore Nano. To open or create a file with Nano, you should be in the folder you want to create the file in, or you can use a relative path for that. I'll do the latter, the relative path. So I'll write nano src /main.py and hit enter. You'll see that a program started running in the terminal. This is a command line text editor. We won't normally use this to create Python programs, but we'll also often have to use this to edit files when we're working with a remote computer, so it's very useful to learn. It doesn't support the mouse, so don't try to click anywhere. The commands that are possible to run are listed at the bottom. Generally speaking, you hold Control, that's the little caret that is before the command, and then the key that it indicates to run that command. You also have that M, which stands for the meta key, which is usually your Alt key. So that's undo and redo are the two ones that are via that one. Okay, so for example, if I wanted to open up the help, I would hold Control and type G, and that would open up the help. And if I want to close the help, Control X. And so the commands that you can run basically are at the bottom. But normally we'll just be typing programs. And so I show a program here in the slide. That's the one that I'm going to edit real quick. Don't pay too much attention to the actual Python program. I'll explain it, but we will go over Python programming syntax in another video. And so I'm going to type a comment that this program is an example, just an English comment. I'm going to import the time library. I'm going to write file variable is going to be open, so use the open function, and provide a path as a string, time.txt in the results folder. And I'm going to open it for writing. And then I'm going to take that file object, so use the file variable name, and then file.write, which is a function of a file object that it can write out a string. And so I'm going to write out a formatted string. The program was last run at time.ctime. All right. And I'm done with my program. I'm going to write Control X to exit. It's going to say, do I want to save? I'll say, yes, I do want to save. And I want to write it out as source/main.py. All right. And so now that I've done that, I can run the Python program with Python and then the name of the file that I'm going to run. And so in this case, it's source/main.py. Again, use tab completion to make sure you don't have typos, and hit enter. Not obvious that it did anything, but if we were to ls on the results folder, we see there's now a new file inside the results folder called time.txt. If we want to look at that file or print it out real quick, we can write cat time.txt and cat and give it the whole folder, result/time.txt. And it says the program was last run at that date and time. We can also use nano to look at it. Nano results time.txt. It'll open up nano and we can see that same line of text. So, all right, that's a quick example of how to execute a Python file. There's another way to run Python. It's called interactive mode. And so launching Python in interactive mode is as simple as writing Python at the prompt and hitting enter. And now we are in an interactive mode. Python 3.9.12 gives us some information on it, specifically where it was installed and things like that. It gives us a little bit of information. We can type help, for example, if we want a little bit more help information on Python. But most importantly, we see that we have a new prompt. This is the Python prompt. This is different than the bash prompt. So this little $sign was the bash prompt. This is the Python prompt. That means that we are going to be able to write Python line by line here. In fact, we can write the exact same program. This program is an example. Enter. Import time. Enter. The big difference is that these commands are executing as we write them. File equals, not as we write them, as we hit enter, sorry. Open result/time.txt, comma, right, close. And I'm going to make a deliberate mistake here. I'll forget a dot. I'll say file write if the program was last run at time.ctime. Again, I made a deliberate error by not including the period. And I hit enter, and it says there's an error. And I can use the up key, because this is interactive, to access the previous command. I'll use the arrow keys to go over, and I'll add that dot and hit enter. And we can see that this actually had some output, a little bit different. It says the number of bytes that were written. And if we added all of these up, it will tell us exactly how many bytes were written. Each one of these is roughly 2 bytes. And so if we added all these up, it would probably be 26 different characters that were written out. So we're sort of stuck in the Python command prompt, though, right now. How do we get out of it? We type quit and open close parentheses, and we are now outside of the command prompt. But we can see if we do an ls-pal on the results folder, we have a recently written time.txt that corresponds to the time that it is right now. As you can see, creating a file is a more convenient way to edit and revise Python programs, and then later run them through the Python interpreter rather than typing the commands line by line. But interactive Python is useful in that you get to see output immediately as you type it. All right. So to summarize, we can execute Python in 2 fundamental ways. One, we can create a plain text file containing Python code and then run that code by typing Python and then the file name. Or we can launch Python interactively and type commands. So the former is usually the way we do things, though the latter is sometimes useful to quickly evaluate some Python.